Hi guys, sorry that I am not there today. I had to go home this afternoon for a sick baby. Luckily this is somewhat of a review. This section is, we're going to spend just today and tomorrow working on properties of exponents. And so here I've got the four main properties that we'll use: power of a power, power of a product, product of powers, and quotient of powers. And really, what does that mean? So here, power to a power is kind of how I like to say this. So see here how we've got a that's already raised to a power, m, and we're raising that to the power of n. All we do there is we multiply the exponents. So it's almost like distributing them. We multiply those exponents together. So for example, x to the third raised to the fourth is x to the 12th, because 3 times 4 is 12. X to the 7th raised to the second power is x to the 14th, because 7 times 2 is 14. All right, and then the same thing applies when we've got numbers. So 3 squared raised to the third becomes 3 to the 6th, which is 729. So that's a power of a power, or power to a power. Now if we've got a power of a product, so here we've got a times b, both raised to the m power. All we do there is distribute in the m so that we have a to the m times a to the m. Oh, this should be b to the m. Whoops. All right, so here we've got xy raised to the fifth, so that becomes x to the fifth times y to the fifth. Here we've got 2x raised to the third. This is an important one. This shows us that the 3 not only goes to the 2, but also the x. And 2 to the third power, that's how they got the 8. And then, of course, x to the third. And here's a numerical example. So 4 times 3 raised to the second is the same as 4 to the second times 3 to the second. So we can distribute in all of those exponents. All right. Then we've got a product of powers. So this one, it's really important to notice we've got the same base. So a to the m times a to the n. The base there is a. When we multiply and we have the same base, we add the exponents. Okay, so we've got a product, we're multiplying, but we've got different exponents. Same base though, so we can add our exponents. So here we've got x to the fifth times x to the second. All right, that becomes x to the 7th because we had the same base. So we just add our exponents. Here we had 5 x's and 2 x's, so that's 7 x's total. Here, remember, if it's just written as a variable with no exponent, that's technically to the first power, times y to the 4th becomes y to the 5th. All right. Here, 2 to the 3rd times 2 to the 4th is 2 to the 7th. We add those exponents. And that is what happens when you multiply. Now if you divide, so remember when we multiplied, we added exponents. When we divide, we simply subtract. So here we've got a to the m over a to the n. That becomes a to the m minus n. So we just subtract them, right? Like here we have x to the 5th over x to the 2nd. That's just x to the 3rd, right? We just did this when we did rationals last unit. So hopefully this does not feel new or challenging to us, this power, or quotient of powers. Then here I want you to notice something. X to the 3rd over x to the 7th. 3 minus 7 is x to the negative 4th. The next property we're going to talk about is negative exponents, but all you need to know is that that bumps down to the bottom. You might remember last unit I would have asked you here, which one has more? You would have said the bottom, and then I would have said by how many? And you would have said 4, and that's why x to the 4th is on the bottom. All right, so that's sort of a summary. Now let's use those properties. Okay, so here we've got two things being multiplied together. Notice the bases are the same. So when we multiply those bases, we add the exponents. So that becomes x to the 7th. All right, again, we're multiplying our bases. Here we've got coefficients. 2 times 5, that becomes 10. We'll have x. Now we add those exponents, so that becomes 10x to the 10th. All right. Here we've got a lot of things being multiplied. First, let's do negative 4 times 3 is negative 12. Then x to the second times x to the fourth, we'll add those. And y to the fifth times y to the sixth, we'll add those. So we'll get negative 12, x to the sixth, y to the 11th. All right, now if this is what you write and you don't need to write this step, that is totally fine with me. You can absolutely skip that first step. All right, so that's one property. When you multiply your bases, you add your exponents. Here we're basically distributing. This is power to a power. We're going to distribute in that 5 by multiplying. All right, we've got x squared raised to the 5th power. 2 times 5 is 10. Here we're going to distribute in that exponent to every term, so we'll get x to the 8th, y to the 12th. We're multiplying. All right, and then here we give that 3 even to the 2, so that'll become 2 to the 3rd, x to the 9th. Well, 2 to the 3rd, that's 8. So 8x to the 9th, and I need you guys to have that answer. We should not be writing 2 to the 3rd. We can plug that into Desmos to get 8. All right, so that's our second property, power to a power. All right, 0 as an exponent. So anytime you have an exponent of 0, that term becomes 1. It goes away, the variable goes away, and we leave behind just a placeholder 1. So for example, here we've got 2, and then we're multiplying 2 by x to the 0 power. That is going to become 1. So we'll have 2 times 1, which is 2. All right. Here we have x to the 0 power, which will become 1, times y is just y. And then here we just have y to the 0, which becomes 1. All right, so 0 as an exponent. Any term that has an exponent of 0 becomes 1. And then here's the last property, so negative exponents. To simplify a term with a negative exponent, we simply flip it to the bottom if it was on top, or bring it up to the top if it was on the bottom. So for example, here we've got 5 to the negative 2 power. So we're going to drop that down to the bottom. So we're going to leave a 1 up above over 5 to the 2nd power. We want that exponent to turn positive. And in order to turn positive, it must get flipped either down to the bottom or up to the top. So 5 to the 2nd went down to the bottom, which became 25. All right. Now here, 2 to the 8th is going to drop down to the bottom, but 2 to the 5th is not, because 2 to the 5th has a positive exponent. So this becomes 2 to the 5th over 2 to the 8th. All right. Well, here we're going to use our quotient property. 2 to the 5 minus 8, right? We'll have a 1 over 2 to the 3rd, because 2 to the 8th, the bottom, has more by 3, right? And 2 to the 3rd is 8. That's how they got 8 on the bottom. All right. So now let's try simplifying. So here we've got a negative exponent, x to the negative 2nd. To turn that positive, we're going to send it to the bottom. But we have to leave a placeholder 1 up top. Okay, so notice now that we wrote it on the bottom, that turns that exponent positive. Okay, here we've got our negative exponent on the bottom, so we send it to the top. So we'll have 1 times x to the positive 4th, which I would just write as x to the 4th. All right, and then the last one, here we've got x to the 1st and x to the negative 3rd. So we're going to send up that x to the negative 3rd and multiply it. Now it'll become positive. Remember, when we multiply, if we have the same base, we add those exponents, so x to the 4th. Okay, so now we're going to put it all together. So use all of the exponent properties that we have learned today to simplify. So here we have a quotient, x to the 4th over x to the 3rd. When we have a quotient, we subtract. That's one way to do it. So we'll have x to the 1st or just x. Or you could have said to yourself, which one has more? The top. By how many? 1. So we leave x to the 1st on top. All right. You don't have to leave a placeholder 1 on the bottom here because there's always a 1 on the bottom, but you could if you wanted to. Okay, here we've got a combination of different properties. Notice we've got x to the third over y to the second. Those are different bases, so we cannot combine those. But those are both being raised to the 5th power. So I'm going to distribute in that power of 5 by multiplying. 3 times 5 will be 15. 2 times 5 is 10. All right, and now my last one here. I'm going to distribute in that power of 3. I'll have x to the negative 6th, y to the 12th, I multiplied those, over x to the negative 9th. All right. Now to simplify, I'm going to bring down that guy to make my 6 positive and send up that guy to make my 9 positive. And the y to the 12th stays right where it is because that 12 is positive, so it doesn't have to move. All right, so now I'll have y to the 12th times x to the 9th. That 9 becomes positive because it came up top, over x to the 6th. That became positive because it bumped down to the bottom. Now I want you to notice x to the 9th over x to the 6th. Those are the same base, so those can be combined, right? I'll still have my y to the 12th, but now if I look at this, x to the 9th over x to the 6th, 9 is bigger than 6 by 3, so I leave 3 up top with the y. All right. Guys, use those examples to try some cool down problems. See how you do. Remember, tomorrow's a practice day, so you've got just 10 problems to work on. These should be fairly quick. If you need to, you can always rewatch this video or work with each other to get some help. All right, I hope I see you tomorrow, and I hope you enjoyed your long weekend. See you soon.